Okay. All right. Good morning, everybody. We are going to start today. We're going to continue our trig proofs. And so what we're going to start with is the granddaddy equation. So if you would, take just a minute to write that down. And remember, it's just Pythagorean's theorem. A squared plus b squared is c squared. The only difference is that in our unit circle, right, my x is my cosine, my y is my sine, and r is 1. So we have a squared cosine, b squared sine squared, and c is the radius value of 1. Now, there's two variations of this, and remember, you don't have to memorize those, you just have to know how to find them. So remember, here's what we're going to do. Everything you need is right here at your disposal. So first of all, I'm going to divide this entire equation by cosine squared. So cosine squared divided by cosine squared, of course, is 1. Sine over cosine is tangent, and 1 over cosine secant. All right. The other tool you have at your disposal is the sine squared. Cosine over sine, cotangent. Sine over sine, 1, and 1 over sine, cosecant squared. So you should be able to come up with these three equations in a relatively short amount of time. So last night we did A41, or yesterday we did A41. So today we left one problem undone, and that was problem 7. So I'm hoping, and again, let's keep our granddaddy right there. I'm hoping you recognize that 1 over sine squared is cosecant squared. And 1 over tangent, remember, now it could be cosine over sine, but what's going to help us more here is to turn this into cotangent. And now, look here at our last identity. I've got cosecant squared minus cotangent squared. This entire equation is the value of 1. All right, so we're going to continue down this same path. And what I'd like you to do, you should have notes 4.2, trig proofs. Okay, so what's frustrating for students with proofs is that you're not solving for a number or a value. And that sometimes gets a little frustrating to students. But what we're going to do, using our 8 identities, we're going to make the left side equal to the right. So you are not moving things back and forth over the equal sign. You're just working on the left side. In other words, I'm trying to get tan over sine equal to secant. Excuse me. So I'm not going to be moving things back and forth over the equal sign. I'm just going to work on the left-hand side. Well, I know that secant is 1 over cosine. So I've got tangent and I've got sine, and there's no cosine showing at this point. But I know tangent can be rewritten. I can rewrite tangent into sine x over cosine x, all divided by sine x over 1. Now, why would I do that? Because now I've at least introduced cosine into the equation, and cosine will take me to secant. Well, I've got a rational here. I've got sine cosine divided by sine over 1. So I'm going to flip this and multiply. And when I do that, I see that the sine values cancel out. So I've got 1 over cosine, and 1 over cosine is secant. Again, you're not going to be going back and forth over the equal sign. You're working all on the left-hand side. Okay, so let's look at problem 2. Tangent plus cotangent equal 1 over sine cosine. Again, I'm trying to make tangent plus cotangent equal 1 over sine cosine, so I'm going to have to introduce sine and cosine into this equation somehow. So what I'm going to start by doing is rewriting tan and cotangent. So I've got sine x over cosine x plus cosine x over sine x. Okay? We're getting closer, but Now what are we going to do? Well, remember, right to left, left to right, denominator, denominator. Okay, so here we go. I end up with sine squared x plus cosine squared x over cosine sine. So you can see you've got your denominator. Well, how can I change sine x squared or sine squared x plus cosine squared x into 1? Remember your granddaddy equation. By definition, sine squared plus cosine squared equals 1. So here I can change that identity, and I've got 1 over cosine x sine x. And remember, in multiplication, order doesn't matter. 2 times 5, 5 times 2, it's the same thing. Okay. Let's look at the next one. Again, I get very suspicious when we see 1 and one of our trig identities squared. So I'm going back to the granddaddy. And again, I keep writing this down, hoping you will keep writing it down, because the more you practice it, the easier it gets. And again, I'm going to divide by cosine squared. So I have 1 plus sine over cosine, tangent squared, 1 over cosine, secant. And then I'm going to divide by sine, so I've got cotangent squared plus 1 cosecant squared. Well, right here, 1 plus tan squared x is secant squared x. Great, so I'm going to make that substitution, and that's where I am now. I'm trying to get secant squared times cosine squared equal to 1. Well, okay, what's secant? It's 1 over cosine squared. And because that is a fraction, I'm going to turn cosine into a fraction. These cross multiply, and I end up with 1. So using our identities, we can change a lot of what we're looking at. All right, if you would, take out A42, which I sent in the notes a while back. We're going to work the odd problems, and if there's time, we'll go and look at the evens. If there's not, I'll give you the even key, and you can work them on your own and see that you can get where you're supposed to get. Every time I'm working a trig proof sheet, I'm going to write the granddaddy equation at the top of the page. I mix thetas and x's, but it doesn't really matter. Whatever your angle measure is, it doesn't matter. You're going to see as I start writing these more and more, I'm going to start leaving the angles off, and it's just being lazy. It really doesn't matter. I can put them back in later. Okay, simplify each expression to a single term. Well, cosecant theta minus 1, cosecant theta plus 1. So right now, this is not granddaddy because these are not squared. But clearly, when we multiply this together, we're going to get cosecant squared theta plus cosecant minus cosecant minus 1. All right? Here it is right here. Cosecant squared theta minus 1. If I move the 1 to the right-hand side, this whole expression is equal to cotangent squared theta. All right. Now, moving on. Simplify the left side to equal the right. Do exactly what it says. You're not going to be working back and forth over the equal sign. I want tan over secant to equal sine. So to even get in that direction, excuse me, I'm going to have to change tangent. So I've got sine x over cosine x, there's tangent, divided by, well, do I want to write the secant x or do I not? If I do that, I've got 3 terms. I've got sine, cosine, and secant. And I'm trying to get this all to equal sine. So what do I know secant is? Well, I know secant is 1 over cosine. And the reason I make that substitution is because now I've got all similar terms, and maybe something's going to cross out. Clearly it is. We're going to flip this. And we're left with sine x, which is exactly what we were trying to get it to look like. Okay, let's look at 5. Sine over cosecant plus cosine over secant, and all this has to equal 1. Well, again, you're going to be better off if you get some similar terms in here. So we're going to turn everybody into a rational. I've got sine x over 1 divided by 1 over sine. That's cosecant. I'm going to add to that cosine over 1 divided by 1 over cosine. Now I've got all the same terms in there. So let's just look at the sine over 1 divided by 1 over sine. So I've got sine over 1 times sine over 1, cosine over 1 times cosine over 1. Well, clearly sine times sine is sine squared. Cosine times cosine, cosine squared. And there's your granddaddy equation. Cosine squared plus sine squared, a squared plus b squared is 1. Okay? Let's move on. Let's look at 7. Okay, because I'm on a separate page, cosine squared plus sine squared is 1. 1 plus tan squared is secant squared. And cotangent squared plus 1 cosecant squared. And again, don't worry about the angle measures not being there. We'll put them in when we need them. All right. So on 7, I have sine x over cosine squared minus 1. And again, the bells should be going off in your head. We've got a trig trig identity squared plus or minus 1. So right here, cosine squared x minus 1. Now think about the algebra there. If I bring the 1 over to the left side of that, I'm going to subtract the sine squared. So I can replace this. So I've got sine x over negative, be careful, sine squared x. Okay, well, one of the signs is going to cross out, and I've got 1 over negative sine x, and 1 over sine is negative cosecant x, and that's what we were heading for. Okay, look at 9. Cosine squared times 1 plus cotangent squared. Again, there's 1 plus cotangent squared. So I'm going to make that substitute. Oh, and I'm trying to get to cotangent squared. So I've got cosine squared x times cosecant squared x. And I'm trying to make this look like cotangent squared x. Okay, so let's just think about this for a second. Cosecant is 1 over sine squared x. Same identity, just represented in a different format. So now I've got cosine squared x over sine squared x. Cosine over sine is cotangent squared x. Okay? All right, let's look at 11. Sine to the 4th minus cosine to the 4th equals sine squared minus cosine squared. Okay. What are we going to do? Well, we're going to factor, right? Isn't this difference of squares? I'm trying to make this look like that. Okay, well, don't I have sine squared theta minus cosine squared theta times sine squared theta plus cosine squared theta? Difference of squares. And I'm laughing because if y'all remember at the first of the year when we were going through all the factoring stuff, and I said one of these days you're going to factor with no numbers at all. Well, here you go. All right, so we recognize the difference of squares. And what do we recognize about sine squared plus cosine squared? That's our granddaddy equation. So I'm left with sine squared theta minus cosine squared theta times 1. And that's what we were trying to get to. All right. This next one is somewhat of a challenge. Now remember, well, I may let y'all work that one. Let me give you some answers real quick and see. We have plenty of time. Let's go on to 13, and we'll come back and work the evens together, because we really do have quite a bit of time. All right, here we go. Graph the rational. Remember, our domain is determined by the denominator. So my domain is all reals, such that x doesn't equal -1. -1 plus 1 is 0. You can't divide by 0. Which means what? You have a vertical asymptote at x equal -1. So let's go ahead and draw that in there. All right, it's been a really long time, but as I approach that asymptote from the right or from the left, I'm going either to positive infinity or negative infinity. So we need to do a quick little sign analysis to figure out which. So we're going to have x approach -1 from the left. So -1.1 times 2 is going to be approximately -2 and change. Minus 3 is going to give me negative. And -1.1 plus 1 is negative. Negative divided by negative is positive. And now I'm going to have x approach -1 from the right. So I'm going to use -0.9. -0.9 times 2 is going to be approximately, what, 1.8? Negative minus 3 is negative. And -0.9 plus 1 is positive. So on the right side, I'm going to negative infinity. So now we have to find the horizontal asymptote. By the way, are there any holes in the graph? Well, I don't have a common factor in the numerator and the denominator, so we have no holes. Your horizontal asymptote is going to be your largest exponent in the numerator and the denominator divided by themselves. So remember, the -3 and the 1 will fall off. Again, imagine that x is, I don't know, 20 quadrillion. So 2 times a quadrillion, the 3 is not going to matter. It's going to fall off. So my horizontal asymptote is going to be determined by this. So we have y equal 2. Which means as x goes to infinity in the negative side, the function approaches 2. And as it goes to infinity on the right-hand side, it approaches 2. So you can see the curve of your graph by where your vertical asymptotes are heading. There is no slant asymptote. Now the x-intercept. Well, when I cross the x-axis, my y value is 0. So remember, we're going to take 2x minus 3 over x plus 1 and set it equal to 0. The denominator, the nice thing about this is the denominator goes away. So I've got 2x minus 3 is 0, x equal 3/2. So I'm crossing right there, and that fits exactly with what we have. So 3/2, 0. And the y-intercept, of course, occurs when x is 0. So in the y-intercept, I've got 2 times 0 minus 3, excuse me, over 0 plus 1, -3. Okay. I didn't do the curve quite like I should have, but you get the idea. And this shouldn't be bending in there, but whatever. Close enough. All right? All right. Since we're here, let's just stay on 14. Go ahead and take a minute to work 14, and I'll put the answer up for you in just a minute. Okay, let's see how you did. Remember, you're factoring your denominator. So x is all real numbers except for -2 and 2. Because I have a common factor in the numerator and the denominator, I have a hole in the function at x equal -2, which I've tried to represent here. And the vertical asymptote is x equal +2. So I did my sign analysis as x approaches 2 from the left, so 1.9. And I did it with the completely factored form, so I have 1.9 plus 2, which is positive, 1.9 plus 2, which is positive, and 1.9 minus 2, which is negative. So I've got positive divided by negative. I'm going to negative infinity. And then I have x approaching 2 from the right. So I've got 2.1 plus 2, which is positive, 2.1 plus 2, which is positive, and 2.1 minus 2, which is positive, positive infinity. The horizontal asymptote, remember, I've got x over x squared, which ends up being 1 over x, and 1 divided by a bazillion is 0. One piece of candy, all the people in China. You're not going to give them any. So there we go. There's our horizontal asymptote, y equals 0. We don't have a slant asymptote, and our x-intercept would be at x equal -2, but of course that point doesn't exist. And your y-intercept is when x equals 0. So I've got 0 plus 2 over 0 minus 4, 2 over -4, -1/2. And that's what your graph should look like. All right, let's go work some problems together. Go ahead and do problem 2. You've got tangent plus cotangent over secant squared x, and you're trying to turn it into a single term. All right. That's where I'm starting. I've got enough going on in the numerator right now. I'll get to that in just a sec. I'll get to the denominator in a second. So now I've turned my numerator into two rationals. So right to left, left to right, denominator, denominator gives me sine squared plus cosine squared over cosine sine. And now that cosine sine have been introduced in such a big fashion, I'm going to go ahead and change secant into 1 over cosine squared. And now I've got all the same terms. Sine squared plus cosine squared, granddaddy identity. That turns into 1 over cosine sine. Then I'm going to flip the 1 over cosine squared and multiply. That, of course, means I'm going to take out one of the cosines. So now I've got cosine over sine. And cosine over sine is cotangent. Okay. So again, on those type of problems, 1 and 2, we don't have a whole lot of direction. It just says simplify this into a single form. You may have taken the wrong path. Don't let that bother you if you did. Just keep working. All right, let's look at problem 4. How can we make tangent cosecant equal secant? Well, again, we know we're going to have to change our identities. Because secant is 1 over cosine, and I don't have any cosines on the left-hand side. So here we go. We're going to change tangent, sine over cosine, and we're going to change cosecant. Well, that introduces all your same terms. Now you can see what you can get rid of, and of course you can get rid of the sines. So I've got 1 over cosine, and 1 over cosine, of course, is secant. All right, number 6. 1 minus sine squared over 1 minus cosine squared. Again, those alarms should be going off in your head. I have 1 and a trig identity squared. I have 1 and a trig identity squared. So we know that's the granddaddy equation. Let me get up here. So 1 minus sine squared. Well, 1 minus sine squared is going to be cosine squared. And 1 minus cosine squared, again, go to granddaddy, is sine squared. And cosine over sine is cotangent. Not too bad. All right, let's look at 8. Tangent times tangent plus cotangent is secant squared x. Now, there are no squares in here except on this side, and that secant squared doesn't have a 1 involved with it at all yet. So I'm worried that it's going to get... So what do? Well, let's just think about this. I know secant squared is, according to this, 1 plus tan squared. Can I get that? I think I can. And what I'm going to do is just distribute. So tangent times tangent, tangent squared. Tangent times cotangent, tangent, cotangent. So I'm getting much closer to 1 plus tan squared equals secant squared. But I need to change the identity of tangent and cotangent. So I've got tan squared plus, well, remember, tangent is sine over cosine, and cotangent is cosine over sine. Of course, those are going to cross out, and that's going to cross out. And now I have tan squared x plus 1. And tan squared x plus 1 is secant squared. So we've done it. Okay, take a minute to look at 10. There are no squares in here. There's no number 1, so granddaddy's probably not going to jump into this problem. But we've got to start changing some identities. Let's give it a shot, see how it goes. Okay, let's see how you did. I changed secant to 1 over cosine, and of course I left cosine as it is. And then I did right to left to right, denominator, denominator. All right. Now it's really tempting at this point to want to replace 1 minus cosine squared, and you probably should, because what does that do for you? Well, what that does, is everybody okay with this? Remember, right to left to right, denominator, denominator. Okay, so I've changed secant minus cosine into 1 minus cosine squared over cosine. So now I'm going to replace this with sine squared x over cosine x. And where are we heading? We're heading to sine tangent, right? So we're going to expand this. What we really have here is sine x over 1 times sine x over cosine, right? Because sine times sine is sine squared, and 1 times cosine is cosine. So you've got the completed fraction, and now you're having to separate it. And that's exactly where we want to be. We wanted sine, we've got that, and we wanted tangent, and we've got that. And there you go. Okay, number 12, I'm going to need a different piece of paper. It takes up a lot of space. Remember, if you have x plus 5 squared, you do not have x squared plus 25. You have x squared plus 10x plus 25. So apply that same thought here. Go ahead and start 12. We're trying to make sine plus cosine squared plus sine minus cosine squared equal to 2. I'll work it out and show you. Go ahead and start. Okay, let's see if we agree. So I've got sine plus cosine times sine plus cosine plus sine minus cosine times sine minus cosine. I'm squaring these. Sine times sine, sine squared. Sine cosine gives me 2 sine cosines. And cosine, cosine, cosine squared. Then sine times sine, sine squared. Minus sine cosine, minus 2 sine cosine. Negative times negative is positive cosine squared. So right away you should see that your 2 sine cosine x and your negative 2 sine cosine x cross out. So I've got sine squared x plus cosine squared x plus sine squared x plus cosine squared x. Well, sine squared plus cosine squared is 1. And sine squared plus cosine squared is 1. So there you go. Kind of a challenging problem, but you should have been able to get through that. Okay, we've got, let me see, we've got enough time left. Let's move on to 4.3. And again, I wouldn't just quit working these at this point. I would rework these. Take a minute, walk yourself back through them, and see how you do. All right, let's go on to 4.3. Give me just a second. They are smart kids. All right, here we go. Hopefully you have time to gather this sheet. So with your proofs, you're going to work on one side. You're going to look for your algebraic manipulations, adding, subtracting, whatever, any of your substitutions, and just keep going after the answer. So I've tried to make this a little easier for us. So what I'm saying is we're going to verify each of the following identities. So I'm telling you, you need to make this left-hand side look like the right-hand side. So again, you're not working back and forth between the equal sign. You're going to just work on the left-hand side. Okay. Before I even start, of course, what I'm going to write is my granddaddy, cosine squared plus sine squared is 1. This should be becoming easier and easier every time you do it. Remember, all you have to memorize is the cosine squared plus sine squared is 1. Then you just divide it all by cosine squared. Then you divide it all by sine squared. All right, here we go. I've got a rational here, so let's add these fractions together, right to left, left to right, denominator times denominator. Okay? So in the numerator, I've got 1 plus secant plus 1 minus secant, so the secants cross out. And I've got 2 over 1 plus minus minus secant squared x. Remember, we're looking for negative 2 cotangent squared. Okay, so secant squared x, 1 plus tangent squared is secant squared. So again, if I move the secant to the left and the tangent to the right, I've got this, so I'm going to change this to negative tan squared x. So now we've got the negative sign and we have the 2. Where do we get the cotangent squared? Well, 1 over tangent is cotangent squared x. Okay? Not too bad. All right, let's head on to the next page. Now we're going to make cosine minus 1 over sine, equal to cotangent minus cosecant. All right? So we've got a little bit of work here involved for us. I'm trying to think of the easiest way to attack this. And I'm kind of stuck on the left-hand side. Unless I separate this fraction. So remember, if I've got a common denominator, in other words, if I have 3/4 minus 2/4, I can put that together, can't I? I mean, clearly it's going to be 1/4, but can't I do 3 minus 2 over 4? So you're starting in this position, and we want to work back to this position. So I've got cosine x minus 1 over sine, which must mean I had cosine x over sine x minus 1 over sine x. Because I've got that common denominator, I can put that fraction together. Okay? But now you have to work backwards and separate it. Well, what is cosine over sine? Cotangent. And what's 1 over sine? Cosecant. So when you recognize that this is a fraction that's already been put together and you can separate it, that problem becomes much easier. All right, Let's look at problem 3. 1 plus sine over 1 minus sine is secant plus tan squared x. So this is going to be one of the rare times I would attack this problem from the right and make the right look like the left. And the reason I would do that, I've got some room to maneuver on the right-hand side. In other words, I can see when I multiply secant plus tan times secant plus tan, I'm going to end up with a secant squared and a tan squared. And again, going back over here, that introduces granddaddy to all of this. On the left-hand side, I'm somewhat restricted. So that's what I'm going to do with this. I'm going to go after the right-hand side. So I've got secant x plus tan x. And I know what the question most students ask at this time is like, well, how am I supposed to know that? Well, you just kind of, it takes experience and practice doing these. Plus, you have to kind of keep an eye out. If there's that granddaddy getting introduced or the chance to, you have more room to maneuver. So again, it's just experience. And if you didn't see that right away, you probably would have started on the left-hand side and then run into a mess. And then you flip over to the other side. All right, so here we go. We've got secant squared x, secant tan, plus 2 secant tan, plus tan squared x. Okay? So again, I'm going to refer to the granddaddy equation here, and tan squared and secant squared is going to come in pretty handy here. And I'm not sure which one, so let me write this down real quick so I have it off the front. So I have 1 plus tan squared x is secant squared x. So if you'll notice what you're dealing with here, I've got secant squared, secant tan, and tan squared. Before we make any substitutions, let's look at this middle portion. I'm going to move the secant squared and the tan squared together. And then I've got 2 over 1 times 1 over cosine times sine over cosine. Okay? So let's, how much time do I have? Oh gosh, I've only got 2 minutes. We may not be able to finish this. We may have to come back to this. So now, and what I'm dealing with here, I've got 2 sine x over cosine squared x. Okay. Now, the question comes up, if I want to replace the secant squared tan squared, well, there's really no way to do that. Because I can have secant squared minus tan squared is 1. Or I can have tan squared minus secant squared is -1, but there's no way to add tangent plus secant. So now I've got to make another substitution. And I think the direction I want to go, do I want to replace a secant squared with 1 plus tan squared? Or do I want to replace the tan squared with secant squared minus 1? Well, I've got a tangent right here. So what I'm going to do is replace the secant squared right here with 1 plus tan squared x plus tan squared x plus 2 sine x over cosine. We are just about the end of the time here, so I'm going to leave you with this problem, and I'll let you go through the rest of it. Tomorrow, we'll pick up with the assignment of 4.3. I'm sorry, not tomorrow. When are we? Tuesday. We'll be back Tuesday. We have, just to give you guys an idea, we have about 5 more lessons to get us through the end of the year. So what I'm probably going to do is after Tuesday, that'll be our last live shot, and then I'll load everything onto billy.live, and you can just watch it at your convenience. You have all the papers you need. If I find that you need more, I'll send them to you, and then we'll take our work on the homework and the test remotely. Okay, if you have questions, be sure you send them in through Remind, and have a great weekend. That's it.